Thanks everybody for coming out tonight. Thanks people for joining us remotely. Tonight is our presentation by Karl Paulsen, a discussion on artificial intelligence. I want to thank Ramona and Nevada County Media for hosting us tonight. It's always great to meet here. And I just wanted to let you know that the elections are open. I don't know if people received their emails, section members. Elections are open, and we have a full slate of candidates. So I just want to announce who we have. We have John Hinkle here. John's been a manager and now has agreed to assume the position of chair, which no one ever wants to do. We're very, very happy for that. I'm going to support him in that. Yeah. Cindy Dulsdorf was Decoral Marketing, had been a manager back, I think, 2000, so it's been 25 years. So good to have her back, and she's going to help us out with Secretary Treasurer as Mona exits. John LaRon is current manager, but has agreed to stay on for another 2 years. Thank you very much, John. Help out the crew. Yeah, and then Ian Foster. I don't know if everybody's met Ian yet. With New Blue, Ian is taking on a role of manager. Very happy about that. And then also Ian Godfrey. I don't know if you guys know Ian. He was with Envision for many, many years. Miranda the Telestream, and I think maybe 2 years now with TSL. So, yeah, Gresham. Oh, so yeah, so he's joining us as well. So that's it for me. I'd like to do a quick introduction of Karl. So Mr. Paulsen recently retired after 50 plus years in the industry and a CTO for leading broadcast systems integrations firms in North America. Karl is an industry recognized subject matter expert in the media and entertainment technology industry, where he consulted, designed, and led engineering teams in the development and implementation of mobile, studio, and production HDTV, including ATSC digital broadcasting, system automation, advanced media production systems, including the managing of CGI and special effects video production systems. He contributed to the Walt Disney Company, including Walt Disney World, EPCOT, ESPN, Disney Cruise Line, ABC Television Network, ABC News, and ABC O&O stations for over 35 years. He was the creator and purveyor of Diversified's IP Roadshow, a $1.7 million transportable training laboratory, had educated hundreds of broadcast engineers, organizations, and sales teams worldwide in the newest SMPTE 2110 networking technologies for media over IP. Mr. Paulsen is a SMPTE Fellow, SBE Life member, SBE Certified Professional Broadcast Engineer, and a member of the AES and IEEE. Throughout his career, Karl held positions of CTO, VP, and Director of Engineering for leading systems integration firms in the US and Canada. As its chief engineer, he engineered and constructed the facilities and launched KTZZ TV Channel 22 Seattle in 1985, later becoming VP Engineering and General Manager for CGI VXF firm Digital Post and Graphics in 1989. His leadership and management of projects and consulting activities as a systems integrator includes CNN, HBO, Turner, TNT, Discovery, IMF, Al Jazeera, and TV stations including Sinclair Broadcast, Acme, and Nexstar. Karl is an award-winning author, having published articles for SMPTE's Motion Imaging Journal and his TV Tech magazine series Media, Servers, and Storage Technologies, which has yielded over 300 articles on the state and future of media technologies for the digital age. His latest series now include a Cloud Spotters Journal and AI Outlook. So welcome, Karl.
A lot of information to go through. As you can probably imagine, AI is a complicated industry. I guess you could call it an industry now, and I'll give some examples of that. But we'll start out with an introduction of where this all began. And by the way, if there's any questions, just shout out. Hopefully I can overhear them and can pause for a section for a few minutes anyway. We're going to talk about practices and researching that's going on for AI applications, concepts and infrastructures for AI, some basics and some fundamentals, terms and more terms and terms on terms, which have to deal with this entire industry with a whole new vocabulary, the growth of where it's going, some infrastructure changes, which we must certainly address as a systems integration company. I saw these things coming and was taking our company at that time in that direction. And well, you'll see what the major differences of in systems and things are. The elephant in the room, as I call it, on security, protection, and authenticity, and what's going on in research and development in both Europe and the USA. And we'll conclude with what in the world is SMPTE doing with all of this. So we'll get started. So we go back to 1929, effectively, when what eventually became AI, probably more formidably machine learning, began. It started out with a Japanese gentleman who built the first Japanese robot with the idea and the term, which I'm not going to even attempt to pronounce, but you can see it up there, and how it can do learning from the laws of nature. And his robot that he produced, and there's a couple pictures of it here, could change its facial expressions, move its head and hands via an air pressure mechanism, not unlike some of the robots that have been created over the years after that. So this is where the industry sort of said it started. Later on, there were some gentlemen that created some books and some ideas on how to get early stage computers to think like humans, and how in 1921 the Czech playwright introduced the idea of an artificial people, which he named robots for stage and theater purposes. So some of these concepts have been going on for almost, well over 100 years, pretty close to 100 years now. But the term AI was first coined at Dartmouth in 1956 by a group of scientists who gathered together to talk about a summer research project that they named artificial intelligence. Often this is said to be the birth of this first kind of research. Ever since that, there have been succeeding semi-annual conferences on AI research, which have continued from that point forward. One of the things they wanted to make the point on is that artificial intelligence is not necessarily a linear function, nor is the human brain. If you think of what goes on inside the human brain, it's parallel processing things all the time, continuously. And that's really the major point in artificial intelligence, is in order to replicate and simulate what we do as humans, a lot of things got to happen at the same time. And I think you'll figure that out after all the graphics and text that I've got going on here. So another element that came about regarding AI, more specifically machine intelligence or machine learning, was a game in 2014 called The Imitation Game. It was a biographical thriller directed and based upon a 1983 biography called The Enigma, which, if any of you have seen the stories about the compute machine that had to be taken apart or decoded for World War II, this is the parallel that went with that. But 64 years prior to that, in 1950, a gentleman by the name of Alan Turing, the lower right-hand corner there, an Englishman, mathematician, logician, you name it, he did it. But a lot to do with biology, explained in the journal on computer machinery and intelligence way back then, probably long before we thought of computers the way they are now, to test machines through this artificial game called the Imitation Game. And what he did was he took 3 players, typically one male and one female, and then another one either gender at that point in time. He'd isolate them, and he'd use an interpretation algorithm or a series of questions to find out which of the two players is which gender, male or female. And the interrogation is done in written textual form only, so that voices could not give away the obvious answer. The questions would continue until a conclusion is drawn about who amongst the two players is who, that is, who is a male and who is a female. This entire principle is exactly what goes on in AI. You continue to provide interrogation of data and systems until it draws a conclusion and puts that conclusion back out. And you'll see how that works throughout this presentation here. Some of the practices and research that we're employing in artificial intelligence are enormous. There's game theory and AI, where you can read several of these. I hope you can read the screen in your room there, on your screens there. But things like video understanding, computer vision, machine learning, multimodal learning, cognitive science, just a whole litany of different practices and things have begun to explore and use AI. And some of the more interesting things like ethics in AI, where AI and society hit, were large language models, or LLMs, the generative AI, probably most of what we're familiar with when we think we hear or have to talk to a bot on a phone or through emails and whatever. But anyway, you can see that this is no small subject going forward. 3D points in clouds, manufacturing, which isn't really listed here, but AI is going to be quite valuable as we prepare systems that literally live in space and have never originated on the ground. So, some of the infrastructures for AI. Here's some basic fundamentals and some terms. Some of these you may have heard and didn't realize were really connected to AI. The big one, which was quite prominent probably 4 or 5 years ago, is what they call big data, which is a collection of data, facts or values represented in a concept or an idea. The processes included collecting and then analyzing large and complex data sets, aka big data. And in other words, they're used that data sets to extract valuable insights, identify patterns and trends. Well, this took a considerable amount of compute power, as you'll see as we go on through this presentation. But it ultimately allowed businesses to make data-driven decisions based on the information uncovered from the vast amounts of data. Another word for big data was a large data set, which is basically the same thing. It's a collection of that particular data that is so extensive in size that it becomes difficult to manage and analyze using traditional data processing tools. So data processing had to take a switch or a change as well in order to get all of this to work. One of the more common terms you'll hear is machine language, or ML, which is the machine code or the native code that we have to deal with. On the right-hand side here, you'll see sort of the progression and the definitions of where code has gone. Machine code was the very earliest of ones and zeros, if you will. Assembly code was the first more intelligent, higher language type of development. And then the descriptions were here on the right-hand side. These fundamental assembly codes here were the sorts of things that were developed for very early languages like BASIC or COBOL, and eventually Fortran at a higher level language. And these are some of the examples over here on this side, the named functions, how you would add, compare, and convert, and so forth. So this thinking of how machines are going to learn goes back to the late 40s, early 50s, where the development of machine language was essential in order to get computers to where they are today. Another part of this terminology is called generative AI, or Gen AI as it's called. It was introduced over 60 years ago during the 1960s, and has since become a type of artificial intelligence that has been tuned to create content, images, text, videos, and music. It essentially automates the tasks which were previously done by humans. So we're getting closer to this train the brain by a computer sort of concept. And these systems learn from existing data and then generates new data with similar characteristics. That is what we have heard termed the chatbot. Another process in this is natural language processing model, or NLP. It's a cutting-edge field transforming how humans interact with machines, experiencing significant growth due to the increased demand for NLP applications in various industries. And you saw some of those industries in the slide back, a couple slides back. One of the other terms, the AI bot, came obviously out of the word, originally the words robot, but this is a set of software programs that perform these tasks such as NLP or machine language and machine learning automatically. This will give you an idea of some of the NLP processing models that are quite popular today. Pathway language models, GPT-3, BERT, Albert, large languages, various other things like this are all not uncommon if you're working with NLP models on a regular basis. So a lot of people, most people have heard, and many have probably used ChatGPT in some range, but a lot of people don't even really know what the GPT stands for. So here's the definition and sort of the history behind it. GPT is the generative pre-trained transformer. Now, this whole concept of training is an integral part to getting an AI machine language compute system to function properly. The pre-training part comes through users asking questions or inputting things via a chatbot into a system. So a little bit about where this began. It was created by a company called OpenAI. It's a company that created and released the original versions of GPT. There have been several since then. The AI structure was a hybrid organization from both nonprofit and for-profit subsidiary. Microsoft's investment was significant in recent years and contributes significant funding and compute resources. And I'll show you some of that later on. It may amaze you. I hope it does anyway. The OpenAI's mission is to ensure that artificial general intelligence, or AGI, benefits all of humanity. OpenAI was originally founded in December 2015 by Elon Musk, Sam Altman, and other prominent figures in the tech industry. And as of today, although it was a co-founder, Elon Musk is no longer involved in the company, and we all know what he's doing for the rest of this country, at least. In Sam Altman's role, he's the current CEO of AEI and also co-founded the company. So that's the meat behind ChatGPT, and it is an interesting process to go through, and I'll show you how some of the stages and developments of this. So we never seem to have enough terms, both new and old. So another terminology in artificial intelligence is GAN, the Generative Adversarial Network. In 2014, it was predicated to Gen AI, necessary, and was used and founded to be necessary for creating more dynamic things like images, text, videos, and music. A neural network you may have heard of as well. In 1957 at Cornell, it was one of the hottest topics of discussion. It uses applications to draw insights from the massive repositories of unstructured information, and unstructured is the key to what's going on in things like in broadcasting, at least in media management, MAMs and PAMs and DAMs and things like that. It's the methodology to coordinate, classify, and organize data that is not just straight numbers like you'd find in a database or an accounting system. Prompting is another prominent word that you'll hear about. It provides the scientific and specific instructions or queries, that is called the prompt, to an AI model to elicit desired responses or outputs. And how you structure the prompts is how you get the values that you need out of AI. One of the things in doing research for the articles and things that I've been writing is I found out that there actually is a certification program called CPEE, which is Certified Prompt Engineering, which develops an in-depth understanding of large language models and prompt engineering techniques. And it uses expertise in things like blockchains. So let's take a look at the comparative use and the growth from the partner perspective. This diagram, this chart table over here, literally shows how fast things or how slow things developed, including ChatGPT, TikTok, Instagram, Spotify, Facebook, and Uber. This is the number of reaching 100 million activities by monthly users. So that means 100 million inquiries. It took 4.5 years to reach 100 million users per month for things like Spotify and Facebook. It took less than a year to reach 100 million users per month for ChatGPT. That's how fast this technology has developed, enormously fast. And the other ones are pretty obvious what they are. So, and from a dollar perspective, and why there's so much interest in companies to get involved in this, not only for their own use, but for recovery of costs and things like that, is that it's expected that there'll be 158.6 billion partner opportunities. That's people that are participating in this in conjunction with some company, whether that be Google or Oracle or Microsoft or whatever, by 2028. That's an incredible dollar range. And to give you an idea where this and how fast this happened, the CAGR over here, table over there, shows that this really started being tracked around 2021. And it rose very, very quickly from a user speed in terms of billions of people using it. And then at the same time, the Gen AI structures were generating these kinds of year-on growth from points from a CAGR perspective. So after 5 years of strong growth, the expectation is it's 59.3. And note that they believe that this is going to start to level off. For what reasons is they didn't give an explanation, I'm sorry. But somewhere in the middle of 2027, you can see this CAGR growth curve begins to flatten out. Now, whether this means get in now and you'll get the returns here, or don't bother to get in until 2027, it's unknown. You'd have to go read the Canalys report that this got generated. And this data came out in August of 2023, so it's a little bit aged already. But you can see from this diagram here, all of the different AI software developments that are being created. Some of these product names are listed here, but and this is in essence a scale of where it is. The amount of code generators, visual generators, text generators, and audio generators right now is pretty much equally balanced. The amount of design, video, images, and voice and music and so forth is considerably less, but this is still pretty good examples of at least a start of what is probably an exhaustive list. You could probably certainly fill this all up by today. Again, this is August 2023. I wouldn't be surprised if this number is doubled by now. So some concepts related to artificial intelligence. If you take nothing away from this, from an understanding standpoint, Artificial intelligence is basically a branch of computer science that uses computational models to perform tasks that previously required human intelligence. And this is for the first time we can now, as human beings, ask data sets questions and get original information returned to us in things about art, stories, music, movies rather, audio, obviously video, and including broadcasting. I'll give a little bit about that later on. So that's the big point here, is that we're now asking data itself questions about things like that. And it takes a tremendous amount of power to do this. So this little counterclockwise layer gives you, or a set of pictures, gives you an idea of how things have changed from an infrastructure standpoint. This is the before scenes is probably in the last 5 years, because this looks very similar to what you'd find in either a current data center, or certainly in some of the broadcast centers that we've built over the years. But today, where we used to have fixed hardware, and anybody that's in the manufacturing business understands this really well, everything's going to software. So these are all servers that communicate at very high speeds and with tremendous amount of power in order to get the answers that they need. And in the future, this is what the data center, just one cluster inside of a data center, is going to look at. So to put this in perspective, understand that AI systems aren't linear at all. They run in queries, and it takes about 68 queries per process. A process is when you open a session and you ask something like a GPT to start down a path of questions and things like, I want to understand the history of the internal combustion engine. And then you begin to shape your questions based upon both replies and what you expect to get back out of it. We've all been used to using Google search or equivalent or Bing or whatever it happens to be from whatever manufacturer. But in looking at where power was going, a single Google search can literally power a 100-watt light bulb for a total of 11 seconds. If you turn that back around, basically that's the kind of power consumption that it takes. It takes 100 watts worth of electricity for 11 seconds to do a single Google search. And you can all imagine how many Google searches are going on simultaneously. When you go to the AI perspective, such as ChatGPT, a single process or a single inquiry now takes 1 to 2 kilowatts to process that same sort of information. And the results are the process of going and looking through millions of sets of data in order to get that answer. So from an infrastructure standpoint, we have a whole new world we have to deal with. And I'm not suggesting that local broadcasters or small firms at all are going to build up an AI type of system in their current data centers. But here's what's going on now. Computer racks and broadcast racks usually would run between 10 and 15 kilowatts in each one. Today, to do the kind of computation that would be required for AI infrastructure work, it takes upwards of 60 kilowatts per rack, and they're using 400 volt, 60 amp circuits in order to feed that. So that, as I said earlier, is a tremendous change in where we've seen infrastructures to go forward in data centers, and why these data centers you hear about being built and stood up are enormous in size. I mean, they're multiple sets of football field size and dimensions. So a little bit about what powers these animals. We're probably familiar with both what a CPU and a GPU are, but here's the differences. In a CPU, such as you find in a computer or a laptop, it's basically a serial processing function. A GPU, in order to do graphics and the kinds of thinking for AI, is a parallel processing approach. And this kind of gives you a block diagram of what the inside differences were. So you manage the system memory in your system using a CPU, which then inquires of GPU memory and caches to move back and forth between things called shader processors. And this is a graphics example. If you're doing something that's a 3D animation or something of that nature, this is kind of the structural difference. Up until recent time, this is really all you saw in here was the CPU, and most of this was then done in specialized hardware. Now we're doing all of this in software, and that's the complex part of AI versus normal computing. And this is just a list again of what the CPU functions and graphic functions can do. They're best suited, the GPUs, for high performance computing applications. There are many more cores in CPUs, excuse me, in CPUs, but they're less powerful CPU cores. So you don't necessarily count a GPU by the number of cores it is. You count it, you gauge it by the amount of power that particular process can handle. So this is give you some ideas of what the infrastructure changes will look like. There's a kind of an artist's conception of power being delivered to transformers that then turn into backup and generator systems, because you don't ever want these to fail. The power buses are then distributed to systems that have fan coil air handling units and a networking room off to the side. This is a fairly typical data center sort of thing. Chillers and cooling systems on the left hand side here have to keep this tower. Now, that's not all data centers are built this way. There's some data centers in the Raleigh-Durham area for a particular networking company that we visited a few years ago and had a SMPTE meeting at, that really didn't have any massive cooling towers and chiller systems in it at all. They literally cooled it by blowing air, opening windows and passing air through and drawing it through the systems. They had automatic systems to shut the windows if there should be pollen, a pollen day or a bad day or a storm day or something like that. But they generated and created all of this compute power without having to have massive cooling towers and chillers. Now, whether that'll be sufficient for the extra power that these GPU-based systems draw is yet to be seen. You can see one of the systems up here in the upper right being constructed. So again, another look in detail of what the rack systems and so forth look like in a data center. So from a seminar that I attended with Legrand, major manufacturer of rack equipment and rack mounting equipment, they said that rack systems are no longer a commodity. The interesting thing is that with the amount of equipment that they're having to house in these things, raised floors are no longer required. They just can't support the gear anymore. So they're putting them on flat concrete systems and running any cabling overhead in most cases. Along with the cabling, primarily and mostly fiber optic interfaces, the power rails that run overhead from the power systems are in multiple kW sense with a near kilovolt type buses and so forth. So a lot of the down converting, in order to get this to 400 volts or whatever the nominal equipment voltage would be, it's literally done right at the rack itself, as opposed to lowering it to 120 or 208 or 240 and distributing it using conventional systems like we've seen in broadcast infrastructures. So that's where we're going with this. And here's an interesting statement from Microsoft via NPR and others. This is 3 Mile Island, and any of you that have been around and long enough to know the nuclear world, 3 Mile Island was shut down many years ago because of a meltdown in the cooling system and in the reactor itself. Since ChatGPT consumes 25 times more energy to create an answer than a classic Google search, according to securities.io, to build new systems requires a lot more power. So Microsoft is spending its money to resurrect the 3 Mile Island nuclear power plant, which is about a 3-hour drive from my home here in Pennsylvania, with the idea that it's going to create approximately 3,400 new jobs and bring in $3 billion in state and federal taxes, according to Microsoft. And it'll add $16 billion to Pennsylvania's GDP. This is under construction right now. It's to be called the Crane Clean Energy Center after the CEO who was one of the founders, former CEO now, of the company called Constellation, which is the parent company behind all of this. So nuclear power is coming back to the area, and its sole purpose is to power Microsoft's AI facilities that they're building out there. Here's another little statistic about how power density changes in racks over the years. 2019 to 2023, you can tell by looking at this that we're getting in the 70 to 100 kilowatt per rack type system as a result of the needs for the equipment that's going into these facilities. This will give you a little bit of an idea of what's going on here. NVIDIA is a big player in AI. They created what's called a deep GPU accelerator, their product name obviously. The power consumption in one of these DGX units, which looks like this over here, is 12 kilowatts plus the power to run the gigabit switches that have to feed each of these. One data center won't be practical to have or any of the data centers that are going forward won't be practical to house just one DGPU per rack. They're aiming towards as much as 30 to 40 kilowatts per rack because they have to put multiples of these. And by the way, rack sizes now are going to start to nominalize around 50 plus rack units high per rack and several hundred in any one given facility. So it takes imagination and restructuring to figure out this design and to think forward as to what these are going to look like in the future. It's tremendous investment. Billions of dollars will go into these facilities. There are already multiples of these. I couldn't find any place that could say off the cuff how many data centers have already been built. But we know there's got to be quite a few of them given what's going on in the industry right now. So if you're a starter or a newcomer to this world, do you start over? Do you start from the beginning? Well, effectively, no one can afford to essentially start over from scratch. So we have to think about the future. We need to integrate new solutions into existing data centers. Can we migrate over time? Can we, obviously, if you're built on computer floor, that probably means abandon the computer floor. But that, in most cases, if the computer flooring is a foot to 18 inches, that's going to give you the extra 10 to 15 rack units before you get to where your power infrastructure is. So there are ways to go about integrating newer, higher performance data centers in there, but it takes a lot to begin this again. So to start and continue to operate at the same time. Companies such as Apollo.us, they enable by developing software and management systems for the co-location and hybrid clouds provided to harness the potential of AI. So in essence, these are a lot like clouds in that it takes a lot of space, a lot of devices, much like clouds do, that are the data cores behind the AI systems themselves. So from an AI development standpoint, here's some steps and some things it can take. And this is, I apologize for this being the size that it is, but this is what the graphic provided. This is clear back in the 1950s when Alan Turing, who I explained earlier, went, here's where the chatbot capable conversations started in 1964. In 1999, you may remember Aibo, which was Sony's robot that they developed and showed. It was 2002 when the first massively produced robotic vacuum cleaners, the Roomba, learned to navigate homes. All of these required portions and concepts of what's in AI today, but obviously not on the data scale that we have for some of these other processes. Apple integrated Siri in 2011, and Amazon launches Alexa in 2014, and ChatGPT was available for public testing in 2022. And that's as far as this list goes. Some of the development cycles literally have a life cycle involved, already established, and this is what people are using to base how we develop the software and the interfaces to the humans. Starting out with problem identification, data collection, model selection and training, model development, model evaluation and validation, development and integration, and then monitoring and maintenance. So that's a little bit about what the AI development timeline looked like. Here are some actual steps and stages that you might take in creating a system. And you can do this both in software yourself, or you can develop. There are courses and plans where you can learn to take schooling on how to do this yourself. But in essence, these are some of the stages here. These are the general steps in an activity which are normalized for generative AI. There's the Gen AI bot itself. There are the prompts that have to get in here. Here's the data inputs, and then after it does its number crunching and so forth, and its outputs. So this is the tool, the interface to be tested for the activity. The prompt is the task or instructions given to the Gen AI bot. The input is the prompt or content entered into the Gen AI by the user itself. And then this is the content. The output is the content that the AI bot generates from user inputs based upon its responses to the user inputs itself. There is a consistency here. In order to get the generative AI products and bots to work, there are a number of steps that need to go into it, and we're not going to get into the depth of that because that's quite literally down to the line-by-line infrastructure and discussion of how you do the code work. But it gives you an idea here of there are sequences and steps that you must go through. And users must understand they are important. It is important to get this query right. You can take an answer from AI off in a direction just by changing some of the parameters of the prompts. So on the left-hand side here's the prompts that are used for the Gen AI bot itself. The output evaluation criteria is loaded into here. You need to have a clear, constructive, and effective communication process, which is this middle section. There must be accuracy because your output's based upon how thorough you address the prompts to the bot. The intention of the alignment. What is the intent of the original message? What does the user experience look like, or the UX, per the purpose of the activity? And then there's a set of comparative overall results based upon expectations of that activity. So one of the things you want to do is look at the audience that this is going to address. If you're going to address something with an output for a third grader, you better not start talking about in terms of sixth graders or high school or junior high. You have to construct your prompts, your questions to the AI system based upon what kind of audience is eventually going to use this. Otherwise, you're going to get a very coarse result and may have to abandon those results because they don't make any sense. This is about what's called dynamic design. Now, this is the process we hear most about, and that is things like developing fake answers or artificial answers and things of that nature. And AI is now being used in website development because it can collect data that is scrubbed from the user, unless you're going to go incognito, which case all bets are off as to what the answer is going to be. But there are interactive elements. This is the incorporation of animation, effects, click or hover buttons. We all are experiencing this whenever we go to a website. What happens there? There's a visual hierarchy. That's the resizing and the automatic adjusting of the graphical elements that drive the user's attention to more important elements on the page. It's interesting to watch web pages which are accessed by one person in your household, and they go back. The next person goes back to look at what you had looked at on their computer, and the results are completely different as a result of what information it was collecting during that process, right down to the point of where the mouse was, what it looked like, what it clicked on, what it didn't look like, what you didn't click on, or what you bypassed, and how long you were on a particular web page. All of that information is now being collected to help the sponsor of that particular web page develop an answer which is more in line with what you would want as that particular user. So you've got a responsive design, which includes flexible layouts or grid designs. That's how are they located on the page? What's most interesting? Is it stuff or things hidden behind other items that you need to click through or click beyond, and so forth. And then there's what's called intuitive navigation. These are the logical pathways and clear menus that change dynamically to help the users navigate sites easier. So like if you went to an Etsy site, for example, and we're looking for t-shirts, you have to do a lot of picking and choosing on that. All of that information is being collected by the Etsy system itself, so that the next time that you go back to look for t-shirts, it's going to bring up the things that you did first or last, first through it, but the last time that it looked for it, to see if it can get you closer to an answer by spending less time on that particular web page. So all these kinds of companies, Facebook's a perfect example of that, using AI in its systems in order to make sure that you are attracted to the advertisement and the sponsors that it wants you to be attracted to. So where's all this AI stuff headed? Well, we've heard about virtual reality or VR. That's well into the AI world already. Training is for disaster relief is using VR a lot. It's gone well beyond gaming, which is where VR really got its roots. Economic and climate change evaluation, at least as we understand it today, and skills transformation. That's taking the workforce, using what they are experiencing today and saying, this is what you're going to have to know tomorrow. So that's some value propositions behind VR, which is leveraging AI tremendously right now. Then there's augmented reality. That's on every mobile device made today. I don't care who it is. The IT and the OT, or operational technology convergence, with competency centers and self-training. This is where augmented reality helps a great deal. When the Boeing company was manufacturing and developing the 777, the 777 aircraft, they used an augmented reality system. And literally before they started putting welding and steel and making parts and so forth for it, they brought their mechanics in, had them put glasses on, and literally went through the process of, for example, changing the tire on the aircraft itself. This was long before AI is what it was, what we know of it today. But they were collecting that data. They were looking at how many different actions the mechanic had to do before they built the product. And then they went back once the product was built and compared the data to what it really took to get some feedback as to whether that was really happening in the way they expected it. Could it be operationally efficient to build something that way? And I'm sure there were many, many changes that went on before they finalized any one particular feature or set. We all know that convergence tech is coming at us, where humans are being replaced by machines in some form. We all also know we can't fix it today, a car today, without these sorts of technologies. And there's the letter acronyms include operational technology, IT or enterprise level information technology, and the Internet of Things, including OTA, over-the-air software updates, cloud solutions, and real-time analytics. This is where AI hopes to speed these processes up and make these functionalities more efficient. So you wonder what goes on in thinking about AI networks and workflows. Again, some of this has been repeated in different ways here, but here's the steps to implement an AI workflow. You need to choose the right AI tools. So that can be done by inquiring through a ChatGPT function. You can go to places like GitHub where there are libraries and do this yourself. Then you need to integrate those tools, put the puzzle together. Then you need to manage the data sets that you have access to in order to get the answers that you need. And then you basically have to overcome the common challenges of the answer. Is the answer correct? Did we go too far? Did we repeat this over and over again to the point that we exhausted every possible activity, but we still didn't get the answer we're looking for because we don't know what the answer should have been? That's what's going on inside of AI workflows. Another example of it down here. And here's really the steps for AI development. Is the training of the systems, the optimization of the systems, and the deployment of the systems, whether it be a satellite, wireless, or whatever it happens to be. So those kind of are real quick topics about networking and workflows themselves. One of the benefits to AI is that it provides the ability to make predictions, and this is kind of the loop around. Data preparation is one of the first steps. Then there's feature extraction. What do you want to do? You get this by defining the prompts and so forth. And then you put it into the training model. And the model trains the systems and it tests the data over and over again with feedback to the features extraction, where if it finds something out, it goes back to the feature, it extracts that feature, it runs the model again, eventually results in a prediction with outputs from those predictions back to the systems. So whatever it determined here creates data, it goes back into the data pool, if you will. It also goes back and says, we use this feature extraction to do these sorts of things. So this particular phrase is called interference. In AI, it's what happens when a trained model is used to make predictions. And training is the key. Data is what supports that training, and bad or too little data invalidates the model. All of this seems to go from just straight machine language learning to what we call deep learning. And this is what teaches the computers to process the data in a way that is inspired by the human brain. And then this goes back to this parallel processing that I talked about. We as humans don't even think about this anymore. What's going on right now in the development for AI is trying to do these sorts of things that are mimicking the human brain as best as possible. I mentioned earlier there's ways to learn this material. Probably not a day goes by that somebody doesn't get something on their Facebook page or on their email about sign up for this particular service or whatever. We'll teach you how to deal with this. This is really pretty important stuff right now. And these are the stages to maturing to learn machine learning from a workflow perspective. If you go to the company called datacamp.com, you can see what kind of tutorials, and they aren't terribly expensive, oddly enough. But if you think your company is going to start going into this, or you want your company to go in that direction, or even yourself, it might be wise to convince your managers or your superiors to start training some of this and covering some of these costs. And we're talking $30–40 a session type of thing. And some of the sessions can be 6 to 10 days. Some of them I've seen, and I've taken some of them are in the $500 or more type of level. And they teach you a lot. They're very valuable. Some of them are very good. Some of them I think are gimmicks, but it's up to you to go find that out. So here's another diagram of the workflow diagrams. Primarily, these are the steps that you have to go through. You need to understand what the problem is. If you can't write the problem down, don't bother asking ChatGPT. It won't figure it out. You need to prepare the data that's available. You need to convert that data. Now, you yourself are not doing these two steps here. The machine system should be able to do that based upon the prompts that you give it. Then you're going to process that data. You're going to train the machine to iteratively go over these questions and solutions over and over again until you can get an evaluation and analysis and some answers, some output. Then you're going to deploy the solutions. That was the inference process. And then you're going to either retire or replace the answer itself. So we've heard the terminology neural networks. This is a very simplified but complex diagram of what neural networks are. Artificial neural networks, or ANNs, is a simple traditional neural network where it aims to solve trivial tasks with a straightforward network online. Now, this looks almost very linear in fashion, but in essence, by looking at all the cross sections, all these different layers in here, all of these are different computational functions which go out, get data, test the data, see if that's the appropriate answer or not, and then move that data into the next layer, into the next layer, into the next layer. So this is a pretty low-level task comparatively. Neural networks can start to get very complicated, and deep neural networks, or DNNs, have complex hidden layers with a structure that is a wide variety of differential layers, a convolutional layer, max pooling layers, dense layers, and other unique layers. So you can see that this has gone from a fairly simple 1 or 2 layers, if you will, to multiple sets of layers across here. And again, this is much closer to what the human brain is doing when it sees an object, or when it senses something, when it tastes something, when you have another sense disrupted. Your brain's doing all of these things to place an output at the other end, which has been tested in your own mind as to a rational and proper answer. So the DNNs basically in scale to mega layers. These are just, we're showing 4 basic layers here. Mega layers means tens of thousands, if not millions of layers the data processing goes through in order to get an answer. And some of this is very familiar to self-driving automobiles, because they have to have, each one of these may be a data set as to how to react to a lane change, or an object that's in the way, or a stop sign, or a headlight that's flashing in your face, all of those sorts of things. These sorts of things are happening in these products from companies like NVIDIA, who builds a lot of the graphic systems that you find in automobiles that are self-driving and have self-driving capabilities. So here's an example of how one can do a construction of a neural network itself. This is an example of an audio equalization curve. The math is superfluous, but you can see in each case, certain sets of functions have to happen, and it's not unlike what was shown in that neural network. Here's the software human interface, if you will, that allows you to filter that. But in the old days, you literally had to plug in wiring to connect that and turn switches on and off. Today, it's all software based. And this is not unlike systems that are found in studios. I'm reminded of attending the Jimmy Fallon studio in New York, where above every chair, or close to maybe every third chair, was a speaker. And that speaker also had a microphone in it so that it could retune the audio based upon the people that are sitting right there in line between the speaker and the microphone itself. Now, it wasn't recording a person necessarily, but it was getting sound waves when there was a lot of clapping and someone is trying to talk over the clapping, or when the musicians in the band were playing, they wanted their sound equal so that each person got the same experience no matter where you were in that facility. That's a monumental change in the way acoustics used to be handled inside of theaters or performance venues. But this is happening more and more in more permanent facilities. You can't easily do this in temporary facilities, but you would be completely amazed in how a theater on say a cruise ship theater actually functions, and how many sets of these kinds of things, of speakers and microphones and recovery systems, are used in order to make sure that everybody gets the same experience, whether you're sitting at the front of the stage or the back of the auditorium or up on the very, very top level. I've seen this. I've seen it being tuned. Had the fortune of actually going through this with Dolby and how they tuned the systems for motion picture theaters while on board the ship. So we're not going to get into this except from the standpoint of TensorFlow is something that you may have already heard about. But this is the start of what a library would look like. This can be written in Python. It can be written in GitHub. There are libraries that are developed for doing this, and TensorFlow is an open source library developed by Google, meaning that anybody can use it. It imports a sequential class from a model called TensorFlow.keras, and then it pushes it into the systems, and it becomes something that you can begin to develop and tune your own prompts for AI purposes itself. This is the use of existing libraries in a AI mega center. This is what the TensorFlow script looks like. This is what TensorFlow does. I bring this up because Google is probably one of the more common and open systems that allows you to do this and learn and experiment on your own. And these are what the different agents and so forth are that are invested in TensorFlow. So it is a rather complex. I don't suggest you just willy-nilly go out and try and do this yourself without a lot of background, a lot of experimentation beforehand. And again, some of those training courses allow you to do this if you're so interested. So we often wonder and hear about things where AI went wrong. And of course, the funny question is, what could possibly go wrong with AI? It's got so much data, can be so well tuned. And I'll give you an example. Argentina wants to use AI to predict future crimes. And here's the article about it right there. Is this truth or fact or fiction? And many of us probably remember the Tom Cruise movie called Minority Report in 2002, a Spielberg movie, where they were literally trying to predict a crime before it occurred so that they could tone it down. Well, I'm not saying this is going to happen anytime in the future, but there are certain, to find that there's a country already going in this direction is pretty fascinating right now. And when AI does go wrong, here's some interesting things. This woman has a little bit of a problem with a dinosaur. Errors can be caused for a variety of factors, including biased data, which is a big deal. If you collect a set of data that isn't applicable to the population that you're trying to test, you're going to get a problem. Insufficient training, incorrect assumptions that are being made in the data sets, and privacy violations. And here's a few ideas of or examples of where AI just kind of went wacko on its own. And we all know what fake news is, or at least we think we know what fake news is. This is one that I created to see. what really could happen. This is an example where AI, and they call it hallucinations, where it begins adding irregular components. This is created on this side over here, was created by a very well-known software application that I bet every one of us use or have used in some form, whether at complex level or whatever. It actually generated this additional thumb and put it on there as though it was supposed to be part of the hand. All I did was ask it to say, correct the thumb, not having any idea. And it's a text in the program itself. I gave it this picture here, and I said, correct the thumb, and that's what it corrected it to. It actually added another one to it. So this you could play with yourself if you had the particular program. Then the elephant in the room, as we like to say, is really about security, protection, and authenticity. So these are kind of the concluding sections. Very, very important factors right now, and the biggest concerns about legislation, our Congress trying to understand it, although they got other things on their mind right now. Certainly Europeans have done this for quite a while already. Europe, and in particular the UK, is quite a ways ahead of North America in terms of dealing with this. But there are agencies and entities that are dealing with it. There's the Content Authenticity Initiative with CAE, which is an open stack of software development tools used for checking the validity and the accuracy of the data sets that you're putting into your system. This is how complex this can be on the side here. Then there's a C2PA tool set, which I'll get into in the next slide here. A command line tool for working with C2PA manifests and media assets. It involves JavaScript, client codes. Its pre-release libraries include Python, C++, and C, and it's a robust library for a source of truth. C2PA stands for Coalition for Content Provenance and Authenticity. It was founded in 2021 by Microsoft and Adobe cooperatively together. It addresses the prevalence of misleading information online through the development of technical standards for certifying the source and the history of media content. One of the things that I've had discussions with my colleagues is, how can we be sure that it's real information and not created artificially? There's a lot of work that's already being done with that, including with the SMPTE. We were going down the path of saying, might there be a way to authenticate a lens on a camera? Since you can certainly, you could reflect light inside a lens, and no two lenses are alike. But if you could put a stamp on that, some sort of coating that could follow that particular image from its capture point all the way to distribution, that might be a methodology for precluding somebody correcting that or miscorrecting, falsifying the information. So provenance is very important. It refers to the basic trustworthy facts about the origins of a piece of digital content, the image, whether it's an image, a video, audio recording, or a document. And there's different ways of doing those. Most familiar to most people are watermarks, but watermarks, there's now enough sophistication in AI to disrupt and falsify even watermarks. So those don't count anymore. Blockchain is another methodology to determine whether something was altered from its original state. So we're going down that path pretty fast. In broadcasting, at least in the current and the future, artificial intelligence was a major topic at the Production Technology Seminar in January of this year in Geneva, the European Broadcasting Union Center, which is EBU in Geneva. AI in broadcasting is real and taken very seriously. AI editing, clip search, weather reports, auto obscuring, scripting, all of these things are very important, not just in the broadcasting portion of it, but certainly in journalism and in the newsroom. And it can be diverse. It can also create community through local news. So everybody's going to be going down this path sooner or later, and everybody wants to tag it as AI. Whether that's good or bad is up to your judgment. But there's a concern about the lack of knowledge on how to create safe ID or safe AI. In this PTS seminar or summit meeting, there were discussions about large language models and how to train your own LLM, because it's up to you to determine whether that you pick the right large language training modules or not. How can large scale software, for example, Avid, deal with customer AI? A particular European LLM trainer called Toucan-7B was demonstrated and has national, European, and US LLM capabilities. So obviously European interpretations of certain language sets is going to be different from what we might see in the US, and that could throw LLMs. All of these were standards discussions at the ITU level, which is the International Telecommunications Union functionality, who writes standards for the European world. Standards are certainly needed for ethics, safe AI, and AI exchange. AI may become a public service like the internet for fair access, and there's a focus on deepfakes and trust through the C2PA organization. AI trust in broadcasting. C2PA was everywhere during this summer. The coalition has a great deal of prominence. It's probably as important to the content folks and users and distributors as the SMPTE standards are to manufacturers throughout the world. Vendors and user plans to implement and think it's super. Vendors and users think it's super important to get this down. Number of demos were shown and included how they could be implemented. So this isn't something that just came off the cuff yesterday. There's been lots and lots of work on it. Research and development at the BBC, the NHK in Japan, RAI, other Europeans, all shared their R&D work. This is not unlike what happens and has been happening at the Hollywood Professional Association, or HPA, for years, where they used to show their innovation lab, and they had speakers. In order to get your product shown in the lab itself, which is a demo section, you had to present a paper. It had to be presented for the very first time at that particular conference, and it was there basically to get feedback from users who might buy it. Same things are happening over here in the European area. Fake news detection and C2PA was a huge topic, and a move to include this in the internet only via production and distribution via IP. All of these things are very real right now, and they're things we almost never hear about in the open circuits of services rather for AI. Then the vendors that were there included Sony, Google, AWS, and Microsoft. They all shared their views. There was discussions about the transition that we all know from SDI to IP and from hardware to software, how important that's going to be for the vendors. And AI is necessary for survival, but all of them agreed that we want to do this in a safe way. Since AI generates content for products like commentary, highlights, and so forth, and AI voice assisted paired with VR glasses is the new phone called Google Astra. So look for that as it's coming out in the future. Microsoft's AI agent and Azure have an AI foundry with 1,800 models alive right now. Again, the C2PA came forward. And we're moving towards software-defined broadcasting. It's probably a word we haven't seen yet because there isn't a lot of it. But companies don't want to have to build data centers over and over again. They want to do it in software. Still going to mean you're going to have a data center for the compute capabilities, but they don't want to have to be continually replacing the hardware when software could suffice going forward. There's also development within SMPTE, and this is fairly recent. As you can see, the Task Force on AI and Media is a real organization. It's still continuing right now. It was formed in 2020. It was to bring stakeholders to talk about AI and media and opportunities for standardization, since that's the main mission behind SMPTE anyway. There is an engineering report. It's free. You can download it. It's SMPTE ER 1010 and published in 2023. It was available starting in 2024, so you can get it right now. And there's the link to it if you want it. It continues to evolve, and the technology is not going to stop. So this task force has already been put together, since we're quite familiar with task force which generate new products and so forth, just to be sure things that come in the future can be done consistently. The discussion on the Model Context Protocol, or MCP, is part of this task force. It's being developed now. There are updates to the engineering report on security for AI, such as standards, including ISO IEC 42001 for Gen AI models. And there's a standard discussion item on possible future standardizations efforts. If any of you in this audience are interested in participating in standards work, this is the new standards VP. That's what SVP stands for in SMPTE speak. Raymond Young is available. You can look up this by going to the SMPTE website or email him directly. Very, very interested in getting feedback and participation by people. We need people. To date, there's probably 200 or 300 people that are signed up for the standards community at SMPTE, but there's probably 50 to 100 at most that regularly participate. We could use a lot more. So here's my shameless plug. My column is called the AI Outlook. It's published 6 times a year. The other 6 publications are done by John Foten at Deloitte. He and I both approached TV Tech maybe 6 months ago or so and said, we got to start to talk about AI. So this is my next column is coming out in the April issue of TV Tech, Uncorking AI. You can see a couple of the graphics are similar to that, but it's another summary and textual context of what I just spoke about here with all of these graphics. And that's it. This is me. These are my columns over here. Regular contributor and writer. I love doing it. It's how I learn, and I hope this was of value to all of you. Thank you.
Yeah. Any questions?
His hand up.
I have a question.
Go ahead, Ken.
Hi, Ken.
Thank you for a phenomenal presentation. I've hovered in the background here at SMPTE meetings asking questions that I lead off saying there aren't any answers. And most of the questions were about the validity of data that's being used to train models and how you can assure that the results are positive and productive. So I can't say anything more than I'm just overwhelmed by your presentation. And the only one comment I have is that with all the standards and the efforts to make sure that AI is used ethically and accurately and productively, it assumes that people will follow the rules and will follow standards that may be established. And what are your thoughts about the possibility of entities who are scofflaws and do not want to follow established rules, and the power that AI could give to those rogue actors?
Well, fortunately, and I'm speaking from personal experience and not necessarily on behalf of SMPTE. SMPTE is not a legislative body. And to be honest, there isn't a legislative body for any standards out there unless you manufacture something that's unsafe and results in accident, death, harm, whatever, to people. So none of us had the ability, except through our legislative bodies, to harness what happened with what got deemed fake news. Nobody could do anything about it, except amplify that it was wrong or give examples to counter it. How long that's going to last is anybody's guess right now. The whole concept behind the last few slides I talked about here with SMPTE and EBU and so forth doing this is to make people aware of it and to create something that it may be a watermark, it may be a stamp, it may be a dot, maybe a label that goes on a box, who knows. We're all very concerned about this. I don't know where the path is and where the answer is at this point. I'll be honest, I've probably been studying in depth AI for about 5 years. I thought it was going to be, to my previous employer, extremely important. It required a whole new mindset and development process in order for us to address it. And we'd always get the question from management, and rightly so, how do we make any money out of this? I don't know the answer to that. And if anybody's got a return on an investment model that can be shown, maybe that's where a good start would be. But it's a very complex issue and answer with probably by minds far greater than mine and that deal with this every single day. I did it to learn, and I'm fascinated by it. I'll give you a real quick example. One of my articles, and you can find it in TV Tech. I don't know what the title is or what month it was anymore, but I took a seminar on SNIA, the Software Storage Networking Institute, on how do you value the performance of a data center from a power standpoint. I needed to know that for a project I was working on. So I took notes throughout it. Fortunately, you could capture it, and I still have the recording of it, and listen to it. And I went to ChatGPT and I asked some questions that were raised in the seminar. And I asked it to come back with a report. And amazingly enough, it was, I won't say extremely accurate, but very accurate to the answers and so forth. So this data was somewhere, and it knew how to go out and find it. Well, I went to my editor at TV Tech, and I said, what if I actually use ChatGPT to write an article? And he says, why would you do that? And I said, to show it can be done. So I prefaced it by saying just exactly what I did here is I took a seminar, I had them had ChatGPT regurgitate the seminar without having listened to it, because I don't know whether it went out and listened to it or found it or whatever, but the data sets were reasonably accurate. We weren't down to whether it's a 1 or a 2 or a 3 or a 5, not that sort of thing, but the concepts were all there. And it showed, and I put that article together, and it showed that there is value here. Now, it's the people that are abusing it that you hear most about. The ones that used it to fake their theses or their reports in college and things like that, college and high school. I think that if we can teach our society to be honest, more honest than it probably is now, that could be a really good first step to this, and would probably give us better data sets all the way around. And like I said, you could go on all night about this.
I'll just jump in and just say it's very heartening that these questions are being asked and thought about. That's wonderful to hear that. So thank you very much.
I have a question here in Grass Valley. Notwithstanding the integrity of the data and the content creators' honesty, we have the issue of the power consumption, and it doesn't seem like we can say that we have integrity if we are using the kind of power that's created, that's required to generate this. There has to be a ceiling, you know, beyond which we stop, or we, you know, just like we're constantly expanding, you know, CPU capabilities, we have to be inversely reducing power consumption, or it's not sustainable.
Did you hear that, Carl?
Yeah, and I'm just thinking about how to respond to it, because power consumption involves so many different facets and stages and steps. Climate management is one that comes out in my brain first, and I'm reminded about the lack of sincerity right now that seems to be, at least in our country, towards the climate change issues. And these data centers will affect climate. You're gonna see, just by the fact that heat gets generated, it has to be dissipated somewhere. What do we do with that? Do we demand now that the heat that's produced from these, some think wasteful environments, be utilized for something more functional? If you're a manufacturer that's creating these, or a user, excuse me, a company, I guess is the best way to say it. Let's call it what it is. If you were a Microsoft and we're generating megawatts of electricity to do this, and you just threw the residuals away, shame on them. I don't think they think that way myself. And it's going to take new technologies and new approaches to energy consumption and mitigation problems that are way outside the wheelhouse of certainly myself and probably every one of us in this room. That said, if you go to Europe now, and particularly if you go into areas like Holland or the Netherlands and Germany and so forth, you can't go anywhere without seeing a windmill somewhere. And the farmers have figured out how to manage power consumption and usage. The manufacturers in many cases have. Some countries have amplified the need to put, and it is a little bit sad, although on the other side of it, it's a little bit interesting too, to see these hundreds of windmills that are a quarter of a mile to a mile off the coast in the water, just propped up in the air like that. I mean, that's expensive to build. Then they wouldn't build it if there were some return on it. I kind of feel the same way about AI. We wouldn't build this if there wasn't some need or some return on it. And part of the topic I didn't get into, there's a whole litany of topics there, is what AI is doing for medical purposes and surgeries and so forth. AI was used extensively as a methodology or a model to test the COVID vaccines, which frankly probably saved a good portion of the population on this planet. How could they have done that without it? I don't know. It probably would have taken a dozen years before we would have gotten to a point using manual techniques. So I still think there's great value in this. I just hope it doesn't run slipshod and end up a disaster from the fake or the meanness or the, you know what I mean, by the bad side of the world.
Let me just follow up my question. Nobody likes regulation, but there has to be a regulatory body that says, okay, you can build 15 of these data centers, but you can't build 16 because 16 exceeds the environmental footprint that's sustainable? You know, are you aware of any regulatory work that's happening in response to this changing technology?
Having built a few broadcast facilities in my career, and having gone through probably thousands of man hours of testimony and involvements with legal entities and so forth, because each legal entity in each metropolitan area, whether you build a data center or a broadcast tower or a television station, doesn't matter, it's a building, or an Amazon warehouse distribution, they all go through what they feel locally is their rules and understanding. And frankly, although they got a lot of input from experts in the areas, it was ultimately the people that would stand up and say, oh, we don't want that in our backyard, you know, not in our backyard. We're not going to put an airport there. And the people that shouted the most probably got the right attention, whatever the right attention was meant. I think we got the same problem. You talked about, is 15 data centers enough, or is that the limit? It's never going to be the limit as long as there's companies out there with money to put in investments and stockholders to please, and representatives in their constituencies that can comment about it. And I don't want to get too political in this, but I think you can see where I'm going with this. Congress, frankly, is totally ignorant in what this is right now. Totally. Because they don't even understand what AI truly means and what it can do. Not that I want to stand up before Congress and give a presentation like this, but they should hear it. And those things are going to change over time. It's just, will it be too late? Again, my opinion is not SMPTE's.
Any other questions, or should we wrap up? Yeah? Yeah? Okay. Yeah, Carl, I think we're all good from here. We very much appreciate your time and comprehensive presentation. So on behalf of Sacramento SMPTE, thank you very much.
Glad to do it. Maybe another year I'll have a whole different topic to talk about.
Yeah, well, keep us in mind. We'd love to have you back.
Yeah.
Thanks, Carl.
Okay. Take care.
All right,
Bye-bye.
have a good night.